Hello YouTube. So I have something a little bit different. Usually I do electronics, but electronics isn't the only thing that is in my field of interest and expertise. So something else that I tend to do is precision measurement tools. And we have here a nice auction find that I recently picked up. And this is a Fowler Bowers Holematic. It is a specialty micrometer for internal circular diameter, and it has a fault. So we're going to see if we can fix this. The fault is mechanical in nature entirely, and after research and communicating with Fowler support, there's some fiddly precision work to be done inside the head. So let's give it a try and see if we can restore this to its former glory. Per communication with them, I said the first thing to do was to take the head off the body of the tool to operate on it while it was no longer under tension, because there are springs in there and we don't want little parts to fly off. Oh, and if one of the reasons I'm making this video, or one of the reasons, is I didn't find any reference for this specific problem. When I searched online, there was one related instance in which our pins were stuck in and they weren't popping out. But this is the opposite problem. The pin is stuck out and won't retract inward, which is what it's supposed to do. So I figured it's an unusual problem. Maybe I can give it a shot. Maybe I can succeed in getting this repaired. And if so, it'll be a useful reference for anyone else out there who runs into this issue of one of their Borematic pins in these tri-pin heads kind of having the spring pop under where it's supposed to be. So before we start, we want something to help us hold this in place. Let's see. It's small enough. Well, the Omnifixo might serve well. Yeah, that's okay. So, can I zoom while I'm in? Yes, yeah, I can. Or maybe it's going to be better for video quality just to have the camera be closer. Alright, so let's start by taking this off. So right size, a little smaller. Now we're good. So, I guess I should talk through this a bit while I'm doing this. Normally, for small little bits, I would take a little magnet tray to hold them. But this being a micrometer head, we don't want to introduce magnetization because we don't want the head later on picking up tiny little bits or having tiny metal shavings sticking to it and being more likely to go into the internals. So I'll share a tip for a non-magnetic way to make sure you hold on to your screws, and that is duct tape. And this is the cheap stuff, which we specifically want because it's not highly tacky, it's not highly sticky, so it's going to be easier to get stuff off of that. How can we get you a better angle? Hold on. I'm trying to make sure that you have a viewpoint. Yeah, okay. And then we want to use there we go, stick straight up. Basically want to interact with everything in a not possibly magnetic manner. And sometimes tweezers can end up getting very slightly magnetized, depending on the things you picked up. Like random screws can be very slightly magnetic because they've been picked up by screwdrivers that have, say, sat on a magnetic rail, and they transfer a little bit of magnetization to that steel. In this case, I keep the magnetic bar here on the base, so the tip should not really have any noticeable magnetic effect. Hopefully, in theory. I guess I'm okay to hold this. Also, I'll note that we have a triangle pattern here, and I'm sticking the screws in the same pattern onto the tape that I pull them from. Now, this is under tension, and I don't want it flying off. So, more tape. This is another thing you can do. So what I did there is I folded both ends of the tape over on themselves so that I'll always have a little pull tab to easily release this. It also keeps the end that I'll pull away from the serrations that get cut into it so that it doesn't split and end up with a little bit of tape hard to remove. So now let's take off, or now that we have something to keep that in place in case it tries to spring out, and it'll hopefully stick to that tape. Let's go ahead and remove this last spring. Okay. So now that we're here, I will try to gently extract the head. And we'll want to keep the same orientation. So that was these two aligning there. So what I'll do is I'll take this and let's see about there. So now the top pin, as oriented there, is oriented in the same way as the screws and the head. From what I saw, I don't think that matters, and I don't think screw orientation matters. But with extremely tiny stuff, you could have slight irregularities in threading on very fine thread. You can end up with a situation where the same model screw that should be identical, perfectly identical, has maybe slight issues or is slightly more likely to miss thread going into a different hole than the one it came out of, even though the threads are identical model, the screws are identical model, and they should be interchangeable. So now we can see inside the head, and we can see the obvious difference there of one of those legs of the micrometer head poking out and there being a gap there. I'm going to see if I can look inside of it with a microscope. That's going to be a little off camera. 1 second. Maybe I'll get it on screen. Oh yeah. Okay. Let's get the camera turned on so you can see it on the big screen. Let's unzoom. Rotate. And I guess we'll zoom in again. Some screen-on-screen action. All right. So I'm not sure how well you can make that out. Let's get this in a little bit of more stable position if we can. So we'll need to raise this up, get some more height. That was a little bit too much height. Okay. There. All right. So if we look in here and here, it's still like really dark. That's the problem with microscopy. Lots of light are needed. Let's see if I can get a little extra in it. Okay. So you should be able to see, yeah, if I have my flashlight almost in the way, you can see some pins. So in there, you can see the pin is pressed against this direction. Down here where the mouse is in the way, why am I not using the mouse to point? Let's turn that on. Yeah, there we go. So right here you can see that there's a spring pin and it's pushing inward. We have another spring pin and you can kind of make it out, and again it's pushing inward. Now right here you can see it's pushing this way. So it looks like what's happened is the spring has gotten rotated, and that is why it's pushing in the wrong direction now. We also have little bits of dirt or sand or something along here. You can see the little micro granules, so we'll see about cleaning that out. But yeah, our mission, without hopefully losing any tiny parts, is to rotate that spring pin right there. So let's see if we can do this. Move the mouse back out of the way and turn that off. Get my eyes directly back in the optics. Okay. So I don't know if I can do it this way, but I'll give it a shot. I was able to move it a little bit. Not enough. Okay. So instead, I need finer tweezers than that. I guess I will have to use metal. So I think I'm going to have to try to remove that head. This is like safety off time. And I don't want to score the surface. Oh, nice. Okay. So that came off easy. That's good. And now you can really clearly see that pin right there and how it's oriented in a way it ought not be. So let's see. This is like ultra tiny. These might be small enough. They're the finest tweezer heads I have. I mean finest, I mean smallest. So let's go back, eyes on the microscope. Let's get this out of the way just enough. So we want to hold the other two pins in. We don't want those coming out. We just want to work on this in isolation. And we also don't want it popping out because it would probably be an enormous pain in the ass to get it back in. Okay. All right. That went well. Nothing horrible happened. We didn't have an ultra tiny, hard to find spring pop off and disappear instantly. Now, we need to get a little bit of tension on that spring. What do I have for this? I'm going to try one of these flat scrapers. Dental tools are great for this kind of work. So this will give me a flat surface to try to get under and push the spring over. Or do I have anything that will cup the spring? I have a lot of different heads available, so let's see if I have something for that. Nothing great. All right, I think we're going to go with trying this head. And then we want to do that in conjunction with getting this piece back on. So let's get this behind the spring first, if we can. Will it let me? Nope, we don't want to push that out. Yeah, you don't work yourself out. You go a little deeper in there. One sec. I think one way to do this might be to just thread a little bit of dental floss behind behind that pin, or the spring pin, to pull it out, and then I can just unthread the dental floss. So I'm going to grab a little length of that, and we'll try it. Okay. I wonder if it might actually be easier to try to literally thread the dental floss around it. I'm going to do a little off camera here to see if I can... Whoa. No, 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 no. That almost resulted in the pin coming out. We do not want that. Yeah, you slide back in there, you annoying little shit. Oh, hey. That might do. So it was touching the others because it was kind of pushed up. It was out of the amount of depth it should have been in. So maybe we can just slide it on now. Maybe that's all the problem was and it was too far out. We'll give it a shot. Not quite. Although maybe it's enough that we can thread this again, if we want to try that. Okay. So what I'm doing right now is you can probably see I pulled the loop downward, and I'm holding it just by pinching with my finger. So yeah, let's try this again. Let's see if we can get this back in. So this is what I'm talking about with metal on metal and there being a very slight amount of magnetism involved. When you're dealing with extremely small parts, the tiniest bit of magnetization becomes apparent when you're trying to work with stuff with tweezers. It's in. Okay, now we're going to hold that. Hopefully we don't leave too much wax in there. Okay. We have successfully reoriented the spring. Now let's see about getting everything reattached. So let's resecure our tape. Now everything's nice and in place. This should be big enough that I'm not going to worry about magnetics for the head. Let's adjust upward, I think, a little bit. Yeah, and we didn't really clean it, but given how fiddly that was, yeah, as long as it functions after getting this retained, I'm gonna call that good. All right. So screw from the bottom left. And I've just started that thread. We can move over outside of the microscope now, I believe. All right. So I just started that thread a little bit. I'll go ahead and zoom out just a tad. We will start each of these with just a couple turns. Okay. And we can switch off the microscope. Alright, let's go ahead and get each of those rotated in. We can zoom in a bit more. Oh, let's get a little more light. Yeah, that's better. So at this point, I think we're safe to mostly screw them in, and then we'll take turns with each one, gently torquing down, which I don't have the torque ratings, but from what I understand, the general feel of it is like mild finger tight, which makes sense. It's very thin threading. You don't want to yank on anything. Come on. I have a new respect for jewelers and watchmakers right now, although the stuff they deal with is even smaller. Okay, so we're going to tighten this one. And keep going until I feel the start of resistance. And about there. And this one. Find out where resistance is. Resistance starts about there. Let's go a teeny more. We're good. And it starts to feel resistance there. Teeny bit. Like 2 fingers. Then once more on each. Teeny nudge. Teeny nudge. Teeny nudge. We can release the tape. Sorry, that's what I'm doing. I'm trying to feel along the individual legs to get a sense if one is any higher than the other. And then we can do a little better than that, because I want to know if there's any schmutz in there, if we're going to have to do any correction, because it is a micrometer. So if there's, because we didn't clean it, if there's any debris in there, I'd rather, do things now than later when I figure out I'm getting incorrect readings. And also, if I end up selling this, then I don't want to sell it in a state where I'm not sure, I'm confident of its functionality. So, not a micrometer, but it's not bad. So let's about 9.3. 9.43. 9.46. So yeah, it felt like there was a little bit of difference there. maybe it's not relevant, because that would be in its most retracted position. All right, so we're going to try using it. So far, so good. Let's see if this is... Well, that's plastic, so it flexes. What do I have that is circular and exactly the right amount? And not this, because it wouldn't let it move out at all. Lock line. Yeah. Oh, this is supposed to go out to like 0.5. Yeah, I'm getting 12. Well, it's not calibrated, but this is 12.4 millimeter, which should be like half an inch, right on. And it's only expanding, or it thinks it's only expanding, to 12.009. Or is that something that's adjustable? I think I'm going to, rather than using any force, I think I'm going to look this up. Because that has me wondering. Oh, oh, no, look what happened. So I'm guessing maybe we rotated in the wrong direction, or maybe there's like crap in there that's encouraging it to re-rotate there. So probably what we're going to have to do is fully disassemble and clean with some solvent, and then try real hard not to lose those tiny, tiny springs. But at least this served to show that this can be disassembled. The problem is fixable. The spring was just rotated. Now, the Fowler guys that I spoke to did warn me that each of these pins are meant for the specific slot they're in. So if you fully disassemble this, You can use the tape method or anything else just to make sure that you could put a little pencil mark there or something, and just draw it through. So you draw it over that and over the top that you're taking off, and that'll serve as an alignment mark to know how to put the top back on in case that's relevant. And then you could like write down on some cardboard, just draw the circle, the positions of each, and number them 1, 2, 3, and then like have little bits of tape next to each of those, and take the individual legs and put them in position on tape so that you don't lose track of that. Because, yeah, like I said, the Fowler support people I talked to said that they are specific to the groove they're in, and they need to go back into the same groove. So that's something to be aware of. So repair attempted, briefly worked, and then, oh, I heard it click when I pushed it back in. Yeah, it's like snapping in and out of position. Well, okay. Let's try this again. Yeah, it probably needs to be cleaned to get whatever stuff is in there that's causing that rotation out, because we've already seen that the problem does reoccur. I'm trying to see if I can cause it to happen again. Not yet. I'll fiddle with it more. But even though we didn't get a definitive fix, this video should serve as a useful reference for anyone else who has this problem on how to go about disassembly and correcting that spring orientation issue. And also to show you, like, visually exactly what is causing this issue if it's happening to you. Thank you. Have a good day.